All right, when you take the dot product, or sorry, cross product of I and j, I wrote my two vectors out over top of each other down here, crossed the first and last columns out, and did my little multiplication and subtraction, and then I ended up with 0, 0, 1, which that is the unit vector for vector k, so the one along the z-axis, and that should make sense if you think of your three-dimensional space. So this is your x, your y, and your z. So like the corner of your room, if you've got your x and your y, that's like the floor of, or the two vectors that define the floor of your room. The vector that's perpendicular to that would be the one that goes up the wall. Okay, so those make your 90-degree angles there. That should make sense. Now, if you do k crossed with I, you can do the same process and see what you get. All right, you also get a unit vector, and that one is unit vector j hat. All right, so there's some things to note here. I hat crossed with j hat is equal to k hat. J hat crossed with k hat will equal I hat, and k hat crossed with I hat equals j hat. So I, j, j, k, k, and back to I again. Those are your positive, they equal the positive unit vectors. If you do them in the reverse order, if you do j crossed with I, you're just going to get negative k hat, using that rule that you're going to get the opposite direction. It'll be the same vector as the original, but in the opposite direction. So this will be negative I hat, and this will be negative j hat. So really what that means then, I hat crossed with j hat was our picture up here. The j hat crossed with I hat will give you this perpendicular vector, but it's going down into the floor below you. All right, so hopefully that makes sense in terms of that. Let's take a look now at getting the cross product geometrically. All right, looking at the cross product geometrically, we're going to look at an example here called torque. Torque is a twisting force. It's your force applied. It's moving in a circular direction. So if you think of tightening a bolt with a wrench, which is what this picture is supposed to be, you've got different forces, vectors happening here. So there's three vectors really happening. You've got the applied force. That would be your push or your pull on the handle of that wrench. So that is a force measured in newtons. So what we have is that force coming, oops, there we go. The force is here, so you're pushing or turning that wrench handle in that direction. The radius is the length, the magnitude is the length. So we've got this force or vector heading that way. That is in meters. So if you've got an example where that's centimeters, you're going to have to change that into meters. And then you've got the force, which is your displacement of the bolt. So depending which way you're turning, either that bolt is moving down into the material, or that's your righty-tighty, or you go the other direction, your lefty-loosey, and it takes it out of, so it would go this way, taking it out of the material that it's being put into or was in. So displacement of your bolt, you have it either going up or you have it going down. So as you can see, we have displacement of the bolt being perpendicular to the force that's being applied and the radius. So that is an indication that we need to use the cross product here. Use the cross product. All right, so as I mentioned earlier, if you turn the wrench one direction, the bolt will move in a direction that's perpendicular to the handle and the turning force. But if you turn the wrench in the opposite direction, the bolt moves up. So one is moving down and one is moving up, just depending on which way you're turning. The cross product, and of course that should imply that it depends which way you are doing your cross product. If you have U cross V versus V cross U. So let me just undo that. So one would be maybe U cross V, and the other one would be V crossed with U to make it go in the opposite direction. The cross product will find that vector that's perpendicular to your other two vectors. So that's what we're going to do here. But this time we've got geometric vectors. We don't have our coordinate vectors. So we got to learn how to do that. The magnitude, to get the actual quantity of that displacement for that bolt, we have a formula. It's going to look very similar to our dot product formula, but it has a slight difference. The magnitude of your cross product, so U crossed with V, starts the same as dot product. It's going to be the magnitude of U, multiply, because that's just a scalar, the magnitude of V, and then instead of cos theta, we have the sine of theta here. And that will help us calculate the magnitude. As far as direction goes, we're just going to say up or down. Or depending if we're doing a question in our book where our book is kind of flat, we say that it goes up. If it's going up, it's going out of the page, coming up to our face, out of the page. That's the up. Or it goes down, it's going into the page or into your desk. It's heading down to the floor. So some of the answers in your textbook will be referring to out of the page or into the page. All right, to find that direction, that up or down, we use this thing called the right hand rule. It's difficult to show you what's happening here with that right hand rule. The key is you have to use your right hand, so you have to know which hand is right and which one's left. You got to use your right hand with this. You're going to use your right hand to lay your fingers along the first vector with your fingers pointing in the direction it is pointing. So if I want, I'm just jumping to the example below, if I want U crossed with V, I'm going to lay my fingers along here. My fingers are going along here, and the end of my fingernails should lie here. So this would be more like where my palm of my hand is going to be. Okay, and then you have to curl your fingers. You've got to be able to curl that right hand, the fingers, towards the vector that you are crossing it with, towards that second vector. So if you go to curl your fingers and your fingers are trying to curl that way, it means you've got to flip your hand over. Okay, so I have to, your palm is going to face your second vector. If you think of it that way, your palm has to face the second vector so that you can curl those fingers towards the second vector. You'll notice your thumb is pointing down. It's pointing into the page when we do this. So this is a downward direction. It's an into the page direction here for our example. So let's calculate the magnitude of the cross product. So the magnitude of U crossed with V is going to be the magnitude of U times the magnitude of V times the sine of the angle between them, sine of theta. And that angle between is always when they're joined tail to tail, like this diagram already is. So we're going to have 5 times 12 times the sine of 40 degrees. And we're degree mode. Make sure you're in degree mode in your calculator. 5 times 12 is 60 times the sine of 40. And I get about 38.6 there as my cross product magnitude. And we have the direction of into the page. And I don't have context here, so when I put my therefore statement, I didn't put units with that magnitude amount. But U crossed with V has a magnitude of 38.6 heading into the page, or heading down, you can call it. All right, hopefully that is making sense for you, and some practice questions are assigned. Again, let me know if you have any problems or issues.